CTEC Innovation's main role in the HIGREEW project has been to lead the stack engineering task, and that's really involved working in close collaboration with Pinflow, another electrochemical engineering company specialising in redox flow batteries. And for this project, this has really involved taking the laboratory results that have been generated by other partners into the project and then turning them into a full-size electrochemical stack. This has been involved, doing the calculations around the design of the flows, the leakage currents, and then doing the engineering of turning small cells into unit cells, which are scaling up to unit cells which are suitable to go into a stack like this, and involving generating the designs, all the arrangements, everything's testing, scaling this up to this scale, integrating it with balance of plant into an energy storage system, and operating that energy storage system to generate real stack level data on performance of an organic redox flow battery at a realistic scale. Within HIGREEW, I think the biggest challenge in the project was really to do with COVID-19 and the impact that the serious impact that had on the project in terms of timescales of the research being carried out, the knock-on issues with suppliers and getting them to do work, availability of parts, timescales there, and really the financial impact on a range of partners. And it was the issues around that and coping with those issues, I think that was actually the most challenging bit of the project rather than the technical side. I think in terms of what was the most interesting bit for CTEC itself, I think it was developing a new kind of seal technology for use within the stacks here. That you can see the seals going around the edge of the unit cell and around the manifolds, etc., rather than being traditionally produced by either gaskets or O-rings, which are then inserted. We've been producing these directly in place using a printing technology like this, which is driven by a computer. And developing that technology was the most interesting bit, I think, of the project, and something that I think they're going to use afterwards. I think the project where CTEC, I think, has contributed a lot is that we've got a lot of background on taking a range of different redox flow battery technologies, be that vanadium, be that soluble lead or zinc air, from lab up to stack level. And we've applied that in the project along with our general expertise in electrochemical scale-up for customers worldwide. And from this, we developed skill in scaling up of organic redox flow batteries, which I think is taking it a step forward to maybe being a competitor to or an alternative to the most common redox flow battery technology in the market of vanadium. For CTEC itself, I think we may be able to use the project specific skills in terms of consultancy for people with stack and system design for redox flow batteries, but we see the most use ourselves of the printing sealing technology that we've developed within our own cells and systems. So the HIGREEW project's given us a good opportunity to sort of get to know very well and collaborate with a wide range of organisations across Europe with a lot of skills and expertise that we couldn't find in the UK, or we wouldn't be very easy to find in the UK. So that's the type of thing that we find very valuable about these projects. In terms of sort of exploitation and things like that, even before the end of the project, we've already been discussing collaborations and commercial projects with some of the partners in the projects. So we see that as a very useful outcome as well.